Hello everyone, hope you're doing well. So, in this lecture, we are going to start with the part 3, what I'm calling basics of chemistry. So, in this lecture, I'm going to discuss about the language of chemistry. So, you might have seen a lot of chemical formulas, how they are formed, and how do we write chemical formulas. So, I'm introducing chemical formulas first instead of going into the chemical bonds, but that we'll be discussing in the future classes. So, I'll start this entire chemical formulas part from ions. So, ions, as I've told you before, these are charged atoms. Now, ions are never going to exist alone, they are a part of a chemical bond. Specifically, if we say metal and non-metal, then the chemical bond between these ions, cation and anion, is going to be ionic, or we even call it as electrovalent. That part I'll be covering in the future classes. Then it's not impossible to say that only a metal and non-metal can form ion. They can be non-metals also. They will have some different kind of bonding. So it's better to learn the chemical formulas by learning the language of these ions, like how do we name them and how do we address them, and we need to remember the charge. Then it's quite easy for us to write the chemical equation and even understand bonding. So I'll write it over here. There are two types of ions that we discussed from the previous class, cations and anions. So cations carry positive charge, anions carry negative charge. So I want to add one thing over here. These ions which I'm discussing right now, these are single element ions. I have a different way of teaching the radicals ions part. I always take up single element ion first, ions made up of only one atom or element. So the radicals part, group of atoms having a collective charge on them, that part I'll be discussing later. So the whole point over here or whole goal over here is to make you memorize the ions so that you can easily write chemical formulas with full confidence. So I'll write over here one more point. Ions are a part of chemical compound. They never exist alone. So, when we say cations and when we keep this thing in mind that we are discussing single element ions, so I'll write over here. So, these are positively charged atoms, generally formed by loss of electrons. So, we can change it a little bit. Generally formed by metals, by loss of electron from their outermost shell. So everything is happening from the outermost shell because from here chemical reactions start. It's because of the electronic movement. So for anions we can write generally formed by nonmetals, by gain of electrons in their outermost shell. So the exception over here is again going to be hydrogen for cations, as I've discussed that in the previous classes also. So now I'm going to write the charge Na plus. Now this charge, what I'm writing for certain elements, magnesium 2 plus, we actually call them as divalent. Divalent means their valency is 2. So I can write sodium as monovalent, so its valency is 1. Monovalent, divalent, trivalent, valency 3, tetravalent, valency 4, like that. So now, when we talk about single element cations, the naming part is not going to be changed at all. So, once we will learn this, then I'll be introducing the rules for writing chemical formula. So, name over here is not getting changed at all, it's still sodium. We will call this as sodium ion. Still, it is magnesium. We'll be calling it as magnesium ion. Or we can take it as aluminium 3 plus. This is what we call trivalent. I'll not be writing for every one, every ion over here, just for few I'm introducing so that the term is comfortable for you. What do you understand by monovalent, divalent, trivalent? So this is still aluminium. So aluminium, whether it's in the neutral form, elemental form, whether it's in the compound form, bonded state, its name is not going to change. That's the goal over here. Then if we go to lithium, Li plus, this is monovalent, so its name is not changing at all. Then if we go to zinc, zinc is 2 plus. So some of the valencies in 1 to 20 atomic number you can see in that chart which we discussed in the previous class. So the same valency is the number written over here, this one. So plus charge, why? Because it's a metal. It's losing electrons from its atom. That's a reason. Then if we go to some other examples, we can write hydrogen H plus. This is an exception. It's a non-metal, but still hydrogen has only one electron. It can donate electron to any other atom during chemical reaction. So we will call it as hydrogen only. Then some more example we can write potassium K plus. Then we have calcium Ca2 plus. Then we can write for beryllium also. There's no harm in memorizing it. Be2 plus. So the way I'm writing over here, you have to remember it. Like sodium is plus 1, magnesium is 2 plus, aluminium is 3 plus, lithium is plus 1 plus, or zinc is 2 plus, potassium K plus. So you can remember it. So you can remember from the chart, like sodium atomic number is 11, 281 configuration. So it's going to donate one electron. That one number is valency of sodium. Magnesium is going to donate 2 electron. That is the valency of magnesium 2. Aluminium 3. So that for writing the chemical formula, this whole thing is very much essential. Now we can write some more even if we haven't discussed the atomic number. Barium is 2 plus. Then we can add some more later on. So we'll move to anions part. So anions generally formed by nonmetals, this we discussed. So we have some specific suffix for anions. Like if I have any nonmetal, its name will be slightly different. But once it participates in chemical bonding, its name will be changed. So which part of the name will be changed? That will be suffix. So suffix is IDE over here. Again, I'm repeating it again. Please remember, we are discussing only single element ions. We are not discussing radicals. This is just a learning trick. So please remember it. So now we have N3 minus. That is called as nitrite. Usually nitrogen name, nitrogen, that basically the suffix part you're removing and you're adding IDE. But the valency of nitrogen, if you go to the previous classes notes, it's 3. Nitrogen atomic number is 7, 2 and 5. So it's how many electrons it's going to gain or share. So it's 3. 5 plus 3 if you add it up. So it will give you 8 electrons in the outermost shell, and that will give you the neon configuration. Then we have oxide, O2 minus. We have sulfide. Now I write sulfide as pH. Please feel free to write it as sulfide, your wish. That's acceptable. That's like old format. FIDE, both are fine. Then if we go to phosphorus, P3 minus, that is phosphide. H minus if hydrogen is going to accept electron completing its duplet, so we will call it as hydride. Then we have F minus, fluoride, Cl minus, chloride, Br minus, bromide, I minus, iodide. Then I'm adding some more over here, O2 with the collective 2 minus charge. This is called as peroxide. This is a different kind of bonding, specifically covalent. So two atoms of oxygen are going to form a covalent bond, and they will collectively have a charge of minus 2 on each individual oxygen. Over here it will have minus 1. Then we have O2 minus. This is called as superoxide. So O2 minus. So if we calculate it, so single oxygen is having minus half charge. Now minus half charge, in the valency part doesn't exist. So this is something different. I might have introduced the term oxidation number that we'll be discussing in the future classes. Now something over here. So we have done nitride, oxide. Yes, we have done most of them. So if we talk about these four, fluoride, chloride, bromide, iodide, fluorine, chlorine, bromine, iodine. If you see a pattern, they all are monovalent, and they do have a chemical behavior which is slightly similar. They have same valence electrons that is 7. So I want to add this information over here for these four elements. They actually belong to 17th group of the periodic table. If you remember from the previous classes, groups are vertical columns. 17 group. So it starts like this: fluorine, chlorine, bromine, iodine. So then we have astatine, and then we have tennessine. These are the 6 elements in the 17 group. So we are not going to discuss about astatine and tennessine over here, though they also have 7 valence electrons. See, this there's a reason it's 17 group elements. So it doesn't apply like this all the time, but still, so they all have 7 valence electron, even if you don't know the atomic number. Just remember that. Even astatine and tennessine also. So that means it's going to share or accept 1 electron from its outermost shell in order to complete its octet, having 288 configuration. For chlorine I'm talking about, or 8 configuration in the outermost. That is the nearest noble gas. And another feature that I want to add over here, they all are like fluorine, chlorine, bromine, and iodine, all are diatomic. So fluorine is a gas, chlorine is also a gas, bromine is liquid, and iodine is a sublimable solid. See why I have a habit of interlinking all these, because when we introduce something in chemistry, it doesn't go to your head in just one go. It will take some time to sit in your brain. So you might have to revise it, or be like your teachers might have to repeat multiple times. And then multiple factors are dependent upon your mindset in the class, whether you're listening or not. So any online class, whether you're focusing over there, or your mind is wandering somewhere else, or in the offline class, maybe you're in the mood or you're tired, nothing, like, so many factors are there that why our mind is not perfectly active at the point. So most of my students, what I've experienced is, when they are near to the exams, their focus, their learning capabilities, grasping capabilities all increase, like, I don't know how many, 200 fold maybe. So that's quite amazing, because that time you want to study. So it depends upon multiple factors, but at least whenever we are going to study this entire thing again, you will have a familiarity in your mind that 17 group elements are, they are commonly called as halogens. So salt forming elements, they form salt. Everybody know about this NaCl, sodium chloride. It's a salt, common salt. So these elements have high tendency to form different kind of salts with metals, specifically group 1. So they all are diatomic. Definitely fluorine and chlorine is a gas. Then we have bromine, which is liquid, and most of you might have seen it's reddish brown liquid. And iodine is a sublimable solid, and the color of iodine is very much violet. You can check online about them. Then moving ahead, so once we have learned these for, like, ions, this is like partly done, not completely, I won't say that. So we have started about single element ions. Now this is like one type of charge I'm talking about. Still I haven't introduced the cations like silver, copper, or it's mercury. So still it's pending. So now I'm going to introduce for further cations part. We don't have much of the population of anions in this case, very few are there. We do have a huge population of radicals chart in the anions part, and we don't have much radicals in the cations, like specifically the ones which are very used in chemistry. So cations, or you can say metal ions, having variable valency, we say. So now I'm going to write multiple examples over here. So again, there's a learning trick which I follow. Maybe your trick might be different, whatever is comfortable to you. But if you can remember it, it will be quite easier for the future classes. So I start with iron, Fe. This is basically from a Latin term. The symbol is taken from a Latin term, that is ferro. So we know this is iron. So iron has two variable valency. One is Fe2 plus, another is Fe3 plus. So we have a patterned learning over here. We actually use a suffix ous for the lower valence or the lower number, and then we have ik for the higher valence or the higher number. So the first painful part for you to remember is like cations. Iron is there, so iron can show which valency. Iron symbol is Fe. You have to create a map in your brain. Iron symbol is Fe, so it shows two variable valency. One is 2 plus, another is 3 plus. Which one is the lower number? 2 plus is the lower number, so this is something called as ferrous. Then if we say the one which is having higher number, this is something called as ick, ferric. So this is like, you can say, one way to memorize, or most of the time they will write like this: iron with the Roman symbol 2, iron with the Roman symbol 3. So that indicates a charge. So again, we can come back to the name oxidation number later on. So 2 plus, 3 plus. Now since it's a metal, definitely it's going to show plus charge, it's not going to show negative charge. Then we go to copper, Cu plus, Cu2 plus. We go to Hg plus, mercury, Hg2 plus. Then we go to Ag plus, Ag2 plus. We can go to, so plus 1, plus 2, I'm clubbing it together. We can go to gold, Au plus, Au3 plus. Then we have lead, Pb2 plus, Pb4 plus. We have platinum, Pt2 plus, Pt4 plus. We have tin, Sn2 plus, Sn4 plus. So there can be many, there's no end to ions. We can cover a few common ones over here. So iron is the only in this chart which I have written 2 plus and 3 plus. So I've created a map. Plus 1, plus 2, copper is showing, mercury. Then we have silver. Plus 1 and plus 3 variable valency is shown by gold, that's distinct. Then 2 plus and 4 plus is shown by these three, that is lead, platinum, and tin. So we'll write over here, this is the lower number, plus 1. Out of plus Cu plus and Cu2 plus, which one is having a lower number? The lower number will be ending with OUS suffix, the higher number cupric. Then over here, mercurous, mercuric. Or we can write like this, copper with a Roman symbol 1, Roman symbol 2, mercury with a Roman symbol 1. Then we go to, this is silver, Ag. The Latin term is argentum. So this is argentus, argentic. Or you can write like this, silver with the Roman symbol 1, silver with the Roman symbol 2. Now this is gold, aurum. Aurum is a Latin term. So auris, auric, or you can write gold, Roman symbol 1, Roman symbol 3. Now, next that we need to remember is about lead, platinum, and tin. So I clubbed all these three together so that you can have a memory of these. So lead is plumbum, Pb is a symbol, plumbum is a Latin term. So we can write the lower number 2 plus, that will end with OUS, plumbus. This is plumbic. Or you can write like this, lead with the Roman symbol 2, Roman symbol 4. Then we go to platinum, platinum, platinus, that is your lower valence, platinic, or you can write platinum, Roman symbol 2, Roman symbol 4. Then the last one that we have is tin. The Latin term for tin is stannum. So it will be stannus, or we can write tin with the Roman symbol 2, stannic, tin with the Roman symbol 4. So this is what we have completed for single element ions. So if you can remember all these, that will be helpful, or you can listen to the next video that I'll be in that I'll be discussing about the chemical formulas, how to put them, all this chart, all this language of chemistry into use, into the questions, into the chemical formulas. Then you will understand better. But if you can keep a memory of all these, it will be always good. So thank you for learning with me.